So, find your 4.7 notes. Yeah, just keep the other hand out in your notebook. It says solve by finding square roots. So when I look at example 1 on the left side, I should notice that that is a perfect square trinomial. So it's x minus 4, the quantity squared, equals 25. And then I want us to begin to do something now that we're getting a lot more experience with square root property. I know the square root of 25, so let's skip the step of writing square root 25, and we're just going to put what it is. So then this becomes x equals 4 plus or minus 5. If they are two integers, then you need to continue to combine them. So x equals 9 or negative 1. In example 2, it says find the value of c that makes x squared plus 16x plus c a perfect square trinomial. Alright, so Hannah, what would c need to be if I want it to be a perfect square trinomial?
It would be, you take 16 and do half of that,
Yes?
and then times by itself.
Yep. So half of 16 is,
It'd be 64.
yeah, 8, and then 8 squared would be 64. So we get x squared plus 16x plus 64, and so that's x plus 8, the quantity squared. Alright, so we're going to now do completing the square. But what I need to tell you, when you complete the square, you must make a equal 1, and what I mean by a is from ax squared plus bx plus c. A has to be 1 in order for you to complete the square, otherwise it doesn't work, okay? So here we go. When you want to complete the square, you need to get the x squared and the x alone, so you subtract the 4, and then we complete the square so that it's a perfect square trinomial. Alright, so, anybody I haven't called on yet? I think I've called on everybody. Jaslyn, what would you add to both sides of the equation?
36.
Good job. You're going to add 36 to both sides. So then this is x minus 6, the quantity squared, equals 32. Now, I know 32. I'm going to try to do my square root in the same line. Well, 4 times 8 is 32, but 8 has another factor of 4, so that means 16 goes in there. So it's 4 square root 2. If you are struggling with square roots, we covered that previously, so it is expected that you know how to simplify square root 32. If that is confusing to you, come in at lunch and I will reteach that for you. Alright, so here we go. Example 4. You need to move the constant over to the other side. Now we do need to make sure a is 1, and in this case it's 1. Then we're going to take half of 8, which is 4, and square it. So we're going to add 16 to both sides. Then the left side is a perfect square trinomial, so we can write that as x plus 4 squared equals 14. Then we're going to take the square root of both sides.
Mrs. McInerney,
Yes.
how did we get the -2?
Yeah, it's a positive 2.
Oh, thank you. I do not know. Thank you. So then this is plus or minus, and then the square root of 18, since that's 9 times 2, would be 3 square root 2. Subtracting the 4, I get x is -4 plus or minus 3 square root 2. Okay, so let's kind of go over the process. You need to move the constant over, and then you complete the square and solve it with the square root property. Now, what about in example 5 when there is a number in front of the x squared? Well, you're still going to move the constant, so I'll subtract the 14, but then watch what we have to do. You actually are going to factor out the number, whatever it is, And then we're going to anticipate adding something to both sides of the equation. We're going to use that addition property for equations. But here's the difficulty. You take half of 4, which is 2, and square it. Inside the parenthesis, I'm adding a 4. But what did I actually add on the left side? It wasn't 4. 8. Do you guys see that I actually added 2 times 4, which is 8. So I have to put a plus 8 on the right side because that's really what I added to the left side. Then this becomes 2 times the quantity, x plus 2 squared, equals -6. Then you're going to divide by 2 and get x plus 2 squared equals -3. So then I really am doing this the same way we did in section 4.5 when we did the square root property. Then this is x plus 2 equals plus or minus the square root of -3. Yeah, good job. And did you guys see my t-shirt today? I is telling pi be rational, and pi is telling I get real. I wrote this appropriately for today. So this is -2 plus or minus, and then Noah's absolutely right. Anytime you see a negative under a square root, we pull it out as I. Okay? Alright, so we have one extra step now when there is a number in front of x squared. So here we go. Let's try example 6. We're going to subtract the 150, and then you're going to pull out the 3, but anticipate what we need to add to both sides of the equation. So what is going to go in my first blank on the left? Half of 12, which is 6, and square it. So you're going to add 36. But I didn't really add 36 to the left side. I added 3 times 36, which is what, 108. Combining like terms on the right side, I get equals -42. Divide by 3, and I get x minus 6 squared equals -14. X minus 6 is plus or minus the square root of -14. So x is 6 plus or minus I radical 14. We put I in front of a radical so it doesn't look like the I is underneath the radical. Okay, any questions with these 4 right now? Alright, then let's continue. In example 7, I need to multiply out the left side, okay, because it's in a different factored form. So I get 6x squared plus 48x equals 12. I don't want to bring the 12 to the left because I would just move it right back over. You need to get the x squared and x alone. And then I do want to get rid of the 6. And then remember, we're going to anticipate what we need to add to both sides of the equation. So I take half of 8, which is 4, and I square it. So I've really added 96, 6 times 16. Then divide by 6. So x is -4 plus or minus 3 square root 2. All right, try example 8 on your own. I'll give you a head start. while you're working, tomorrow we're going to spend a second day on this. You'll get a worksheet tomorrow. But tonight's homework, we're on our blue assignment sheet. And you're doing the first row of 4.7 from the textbook. Are you guys getting x equals 1 plus or minus the square root of 26? Yes? Or were you almost there? Almost there. Okay, good. All right. Recall from 4.2 that vertex form of a quadratic function is y equals a times the quantity x minus h squared plus k, where h comma k is the vertex of the function's graph. So one of the uses of completing the square is to help you take a quadratic equation and put it in vertex form so you can read off the vertex easily. So if we look at example 9, it says write y equals x squared minus 10x plus 22 in vertex form. Now what's different about the last 6 examples is they were equal to 0 or equal to a number. And so we have a y and you cannot drop y. I have seen students who just want to take y out and then magically put it back in. You'll actually do it incorrectly if you do that. So we're going to do it with y in there. And so you're going to go through the same steps. You need to get the x squared and the x together, so you subtract 22 from both sides of the equation. So y minus 22 equals x squared minus 10x. Now, there's a 1 in front of x squared, so that's good. I don't need to worry about that. Then I'm going to complete the square. I take half of 10, which is 5, and square it. So I need to add 25, but I have to add it to both sides of the equation. I want you to think of your equation as a balance, and we have to keep it balanced. What you do to one side, you do to the other side of the equation. So then I get y plus 3 equals x minus 5, the quantity squared, and then I subtract the 3 from both sides, and that's vertex form. Then my vertex, it did say then identify the vertex, so then it's 5 comma negative 3. All right, try example 10 on your own. I'll give you a head start. If you want to write an equation, a quadratic equation in vertex form, you're essentially completing the square. When you're done, check that you have y equals x plus 9 squared plus 14. That's the vertex form. And then the vertex, remember, vacuum often in socks only. It's the opposite of the inside, the same as the outside. So it's negative 9 comma 14. Any questions on vertex form? Were we getting the hang of completing the square? Good. Alright, example 11 says the height y in feet of a baseball t seconds after it is hit is given by this function. Y equals negative 16t squared plus 96t plus 3. Find the maximum height of the baseball. Alright, when you see an equation, and I know I've mentioned this before, you need to start visualizing the graph of your equation. This is a parabola because of the t squared, and it's a parabola that's opening down because it's negative 16t squared. So the maximum is going to occur at the vertex. Now, I think they intended us to complete the square, but I don't want to do it with these numbers. So I wanted us to go ahead and review the other way we have of finding a vertex. Remember x equals negative b over 2a? Let's do it that way. It'll be a good refresher for us, and then we don't have to work with bigger numbers. So this is going to be x equals negative 96 over 2 times negative 16. That's negative 96 over negative 32. The negatives are going to cancel, right? And then it's a 3. Is the answer, the maximum height, is it 3? What does the 3 represent?
Your x is t.
Okay, do you notice there was no x in our problem? Do you see that? There's no x, but what letter is really the 3?
T.
The t, okay. So the t, the time, is 3 seconds. What we found is when the baseball hits its maximum height. When? It's at 3 seconds. So how would we find the maximum height? Plug that into your y. Now you may use your calculators. And you're going to plug in that t is 3, or in this case your x. Okay, and remember how we've talked about we want to write our word problems, our final answers in sentence form? So let's remember that. So we would want to say the baseball reaches a maximum height of 147 feet. You could say at t is 3 seconds if you'd like to qualify. Alright, so remember what a graph looks like, and then that will help you with a word problem. Any questions on example 11? Alright, then let's move on to the last one. It says find the value of x if you have the area of a rectangle is 40 with a length of x and a width of x plus 3. So let's play math detective. And what do we know about area of a rectangle? It's length times width. Alright, so you do want to ask yourself in a word problem, what do I know? What am I trying to find? What information did they give me to plug in? So I know the area, and I know the length and the width. Again, I think they wanted us to complete the square, but I wanted to show you there's an easier way than completing the square. The number one strategy you want to use with quadratic equations is factoring, because it is easier to factor than to complete the square. So, can you think of two numbers that multiply to negative 40 but add up to a positive 3? 8 and 5, and it's a plus 8 and a minus 5. Remember, check your work when you factor. Check it. And so I'm getting x is negative 8 or x is 5. Well, can you have a negative length for a rectangle? No, so that doesn't make any sense. And then x plus 3 would be 8. So here's your length and your width. If we had units, we would include the units.